Okay, Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I welcome you all to this lecture number 27 and chapter number 15. So, where we are doing and we shall do integration by parts. So, integration by parts means we have a product of two functions, and we will see that how we will do this integration. So, for example, if you have a function like u sorry and v, and you know that if I want to write its differentiation, so what was the formula? First function as it is and derivative of the second, and plus second function as it is and derivative of the first. Agree? Or you can write it as uv prime is equal to uv prime plus vu prime. Okay, so from here, if you bring this term on this side and this term on this side, so what will happen? You will see, you will get this formula. Agree? And now you integrate both sides. When you integrate both sides, you will get uv dash dx, uv prime dx. Since now this integration and this differentiation is reverse process, so this will be gone. So ultimately you will get this formula. Agree? Now you can represent this function by in a more suitable form, where you say that this v v dash dx is like dv, and u dash dx is over du. So this was your u dash, and this v dash dx is now dv, and this is what is it written here. And the rest of c1 constant is there, plus c1 you will add it. So now it means that the formula becomes u, it was like v dash dx from previously, it was equal to u v minus v u dash dx. So what you did, you write it as, or this u and v dash dx is what? It is the differential of v. So you remember, differential of v is its derivative and then dx, because v is a function of x. So this is this part, and similarly this will become u v minus, and now this v as it is, now u dash dx is what? It's the differential of du. So because u is a function of x, okay, then du will be its derivative and then dx. So this is the formula that we shall use now from onwards. Okay, so let's do how to do it. So for example, you have given a question that find this integration by parts. So you can use any other formula, but if it is asked that you have to do by integration by parts, then you have to integration by parts. Okay, so what you will do, so you will try to locate what is your u and what is your dv, because in the last lecture we have seen that u dv is equal to uv minus v du. And now you will see that which function so you have to pay attention here. Again I am writing for you, so you have to pay attention that v dash means you have to select, we called it like this as the first function and this as the second function. So you will see that, or you have to be careful that whichever is your first function, second function. So you will select the first function and the second function in such a way that the derivative of first function is easily found, and you will select the second function in such a way whose integration is found easily. You got the point? Because for the first function, you see, we need the derivative here, and for the second function you will see here we will need the integration, because this v will somehow, which is here, we integrate and we will get this v. So this is the idea of selecting the u and dv. Okay, so now since we know that if we select a ln of x, so what will be its derivative? U dash is 1 over x. Agree? Can you hear me?
Yes, Dr. Wakam.
Okay.
Yes, lecture.
Okay, so u dash is equal to this. But what about if we select that, what is the integration of ln of x? You know this? You don't know at the moment, but you will see after today's lecture. So what I mean, you have to select a first function u in such a way that its differentiation is easy, or it will simplify this function. Or you will select a second function in such a way that its integration is possible. Otherwise, because here you see v dash dx and we will write it as dv. So here you will see what I mean. So when you take the differential of this u du, and the differential of ln of x is 1 over x dx, and now when you integrate this one, so what you will get? V, and integration of this x to the power minus 1 by 2 dx is equal to power rule. You just add one power and divide by 1 by 2. So this was what? This was, you added one power and you divide by that power, and when 1 by 2, when 1 by 2 comes up, you will get this answer. So I am trying to convince you how to select the first and the second function. Okay, now we know this very well. Now we apply the formula. And what is the formula? Formula says again u dv integration is equal to uv minus integration v du. Now you know what is du. Now you know what is v. You just put in the formula. Okay, so this was your u and this was your dv. Agree? And now it says that it is u dv is equal to u, as I told you here, the same thing. And now you just plug the values. What was u? U is ln of x. And what was v? You just calculated. So this was your v. And this is what your ux is now. I'm just changing the color so that it's easy to highlight. And then you will see v du. So what was v? 2x power 1 by 2. And what was du? 1 over x dx. Now when you further simplify, these two come out and x is power 1 here and it is 1 by 2, so it will be minus 1 by 2. So again here you apply the power rule, 2x ln of x minus 2, and again you integrate 1 by 2 and it comes 1 by 2, so it will be 4. 2 and 2 will be 4. Oops. And press C. And then you can take these 2 common, 2 square root of x common, and this is actually 2 square root of x. And this is the final answer. So you have seen that with the help of integration by parts, you have solved this little bit complicated integration, ln of x over square root of x. Any question? Okay, if there is no question, I asked you to please solve this question by yourself in 2 minutes and let me know. So what is the idea here? That you will select what is u is of course x because its derivative is easy, and what your dv is ln of x because it is integration is ln of x. Agree?
Agree.
No, I don't agree.
No, so one, we take ln of x as a u.
Because I told you this second function be such a way whose integration is easy. Do you know the integration of ln of x? So that is why you have to be careful that u is a function whose differentiation is ln of x, because we know the derivative of ln of x 1 over x, but we don't know the integration at the moment. Okay, and dv is a function whose integration is possible. So now this is the right choice. So this is what I want to emphasize. So now what will happen? So therefore this integration 1 to 2 x ln of x dx is equal to, remember it is u ln of x and then dv 1 to 2 dx. Okay, so what this means, it says u v minus integration and then v du. It means we need a du and a v. So therefore, or you can say now, and here of course you apply this 1 to 2 if you want to write this, and 1 to 2. So now you need du. So du is the differential of this u. So it is 1 over x derivative and then dx. And what will be integration? V is equal to integration x dx. So this implies that v is equal to x square over 2 plus c, whatever. So therefore you come back. So now you write, therefore this 1 to 2 x, so you can write it as ln of x as u here, and x was your this. So 2 into 3 or 3 into 2 is the same, is equal to, now it says uv. What was your u? Ln of x. And what was your v? V is just, you calculated x square over 2. And now you plug the limits 1 to 2. And now minus 1 to 2 v. So what is v here? X square over 2. And what was your du? 1 over x dx. Agree? Any problem?
Clear.
Okay, the rest is you just simplify. So what you will simplify? You put the value of 2 here. So it will be ln of 2 and 2 square will be 4, or you would like to write 2 square over 2 and minus, and this is the formula, ln of 1 and into 1 square over 2. This is the first part, and then here we have left still 1 to 2 x over 2 dx. Okay, so now this will become 4 over 2 will be 2. So 2 ln of 2 minus 0, and here is 1 by 2 constant, and integration of x is what? X square over 2, and you plug the limit 1 to 2. And now further it will be 2 ln of 2 minus 1 by 4. You just take this 2 outside, so it will be 2 square minus 1 square, and now you further write it as 2 ln of 2 minus 1 by 4. So 4 minus 1 will be 3, so it is 3 by 4, and this completes the solution. So what is the, so 1 to 2 x ln of x dx is equal to this number. So I'm trying to give you the idea that I have solved a complete question for you so that you know how to do it. Any problem, you can discuss it now. Okay, if there is no problem, we move forward. So here comes another question. So he just asked us to find ln of y dy. So here there is no other function, but you can write it as 1 dy, and then you select u and dv. Now any idea what will be the first function, what will be the second function? Can you guess?
The, the ln of u is the first function.
Okay, because its derivative is possible. Very good. And the second will be 1, because we can integrate 1 and it will be x or y here. So this is the first step. So now it is very easy. So this will imply, so you need du, it will be 1 over y dy, and you will need v, it will be integration of this 1 with respect to y. So it will be y. Agree? Because now u is a function of y and v is a function of y, because we are integrating with respect to y. Okay, so now we apply the formula. So what was the formula? Again, u dv is equal to uv minus v du. And now what was u is your ln of y, and what is v is y minus v is y, and what is du? 1 over y dy. And this becomes very easy. Y ln of y minus y plus c, and this is the solution, and you can take this y common. So now today you got the integration of what is ln of y, or you can say it is like ln of x dx. So just you put the xx there. Okay, this is the same. Okay, so if this is clear, then we need to further think that how to do it. So here we are getting the solution. Okay, so what can we do here? So what will be the first function, what will be the second? But here you see it will be complicated, and we have solved this question before, you remember? Anyone remember that we have solved this one? Any idea? Mr. Adil, Mr. Abdullah, Mr. Abdullah, Mr. Abdullah. We have, mashallah, 4 Mr. Abdullah. And Abdul Rahman.
We take E.
So you remember we put u is equal to x square, differential, by substitution. Then this x, because we need 2 here, so it means that du over 2 will be x dx. So we have given x dx here. So x dx is equal to what? Du over 2. So e to the power x square into x dx is equal to, so it will be e to the power u and then du. Agree? Now it is correct. So what is the integration of e to the power u? Mr. Ahmad, Mr. Muhammad, Mr. Ali. What is the integration of e to the power u? Mr. Hatim, Mr. Ahmad, Mr. Khalid.
Yes, doctor.
So I'm asking a question that what is the integration of e to the power u?
Half EX.
Mr. Ahmad Ali, are you there?
Yes, here, doctor.
So I'm asking a question, so nobody is responding. Is everything okay there?
Yes, it's about u e to power u.
Yes. You remember e to the power x integration is what? Is e to the power x same?
Yes, plus c.
Yes, so it will be e to the power u and plus c. Very good. And now we put back what is
X
e to the
square.
power x square?
Yeah.
X dx is equal to 1 over 2 e to the power u. U is what? X
Square.
square and plus c. So this completes the solution. Here we don't need to do the integration by parts. This substitution is good enough for us. But if you want to do the integration by parts, you have to select which function is easy and which function is difficult. Okay, so let's move forward. Here comes another question. And this is what we have done this before, I think. Same. Okay. But what is not same here is this example. So now there is a possibility that we need to do the integration by parts 2 times or maybe 3 times. So for example, here what we will do, so we select a first function and the second function in such a way that the differentiation of the first function is possible and integration of the second is possible. One thing, and the other thing is that when you differentiate, we have simplification, and here integration 2 to the power x plus 1. Now you tell me if we have e to the power, for example, 2x dx. So what is its integration? Anyone remembers?
Z-
Say it again. Its integration is e to the power 2x divided by 2 plus c. Agree?
Yes.
So now when you integrate this function e to the power 2x plus 1, it will be e to the power 2x plus 1 divided by 2, because this 2 you need it. Because if you take the derivative e to the power 2x, it is e to the power 2x plus 1 and then 2, and we have to get rid of 2, multiply and divide by 2. Okay, and now so what will be the differential of this du is 2x dx. So therefore, using the formula u dv is equal to uv minus v du, implies or gives u was your x square and dv is your e to the power 2x plus 1 and then dx. And you are going to integrate. So again, u is your x square and v you just calculate it, e to the power 2x plus 1 over 2 and minus integration of this v divided by 2, and what is your du? So du is 2x dx. And now when you simplify, you will get x square e to the power 2x plus 1 over 2 and minus x e to the power 2x plus 1 dx. So we integrate by parts again. So what will happen? We integrate by parts again to this form. Agree? So now we apply directly x square e to the power 2x plus 1 dx is equal to x square e to the power 2x plus 1 over 2 minus. Now you are an expert of integration by parts, so you can apply directly first function x, okay, u, and what will be v, integration of this. Now since you know what is integration of this, minus again integration of this and differentiation of the first. Agree?
Yes.
And now in the last step, so what will happen? It is x square e to the power 2x plus 1 over 2 minus again x e to the power 2x plus 1 over 2 minus minus plus 1 by 2, and again integration of e to the power 2x. E to the power 2x plus 1 integration will be this one, and plus constant of integration. And you can take common e to the power 2x plus 1 and you can further simplify. So this can be written as e to the power 2x plus 1 over 2. And let me change the color. E to the power 2x plus 1 over 2. So what will be left here? X square minus x plus 1 by 2 plus c. Agree? Please double check. Okay, so if you understand this, then this integration by parts concept is very clear. And now we can go further integration by parts. And for this you need just to say what is in the table. This is the list of formulas in the book that I send you the PDF. You can see the formula power rule and just 1 by 2. This is all the list of integration formulas. You can also see the other formulas in the book and take whatever the copy, but you have the book, I think, so no need to make a copy. Whenever you have a problem, you can see the book and the formulas and other formulas also. So what I mean, since this is the last class, I want to utilize this as much as I can so that you can do in the rest in the 2 weeks by yourself. So integration by parts, again the same thing, but definitely the question type is different. So what is this? So we have x dx over 2 plus 3x to the power 2. So it says integration by tables. Table means you will try to do by yourself. You can directly put the answer if you know it. But there is no worry, you can prove it by yourself and I will prove it for you. Okay, don't worry. So for example here, so if you want to solve this question, so what do you think is the most appropriate thing? So if you forget the formula, You just need to do a little bit work. You put this complicated part by substitution, and then you will try to do some of the work. So for example, here he suggests that when we have u du over a plus b u to the power 2, it is 1 over b square, whatever is here, and then the ln of this function and plus a over this factor. And if you want to see what is in the formula, let's see which formula is this one. A plus b u square. So I think this is the formula. Agree?
Doctor, will this be given to us?
I hope in the hint or whatever. If there is a question like this, inshallah we shall provide this formula, okay? But what I want to do is that you understand how this has been developed. But I think it is too complicated for you, and I actually stop it here, okay? So you just see the list of formulas, and for example, x square square root minus 1, x square, what was in, and x square square root minus 1. So we are looking for this formula. So can you check where it is? Or maybe we need, because there are more formula list, I just put the one copy, and let me check the other one. But anyhow, you just plug in the formula and you will get the answer, okay? So for example, this is the formula for dx, and this is the formula dx over this form, and you just plug the answer and you will get the answer. And similarly for this one, you recognize the formula, just plug in the formula. And similarly, this one 7x square ln of this is this formula u to the power n ln of this is by given this formula, and you just interpret, means just manipulate a little bit and you will get the answer. And similarly for, so not needed. So for this one it is not needed. So can you try this one? So you have still 10 minutes. You can try, otherwise I will solve it for you in 1 minute.